Hello everyone, thank you for checking out this video. You are with Coach Julian from Territory Academy. Find the number of ways of traveling from A to B as shown in the figure below if you are only allowed to walk east or north, so can only right or up, and avoiding all the 4 points marked X. What does this question want? It's actually just find the number of ways from A to B, but we cannot cross this. The mark X not counted. Right. So for this question, I'm going to use combinatorics. First is actually to notice that if you want to avoid these 4 points, you must pass either these 3 points. Let's call this point C, D, E. And if you notice, you can only cross exactly one of them. You cannot cross both of them. Any 2 points. You can only cross one. Or in fact, must pass one of C, D, or E. One. Exactly one. Cannot be 0, cannot be 2. But you must always pass. In mathematics, we call this case to be exclusive. This is what we usually call as exclusive. It means that number of way from A to B, we can just count number of way through C plus through D and through E. Right. So let's see one by one. Let's see C first. To pass to C, the number of ways means A to C times C to B. Right, A to C, number of ways A to C, multiply by C to B. But you see A to C, there's only one way. Now let's look at number of ways from C to B. You can do one by one and you can try. But I want to introduce you combinatorics method. So imagine that C will take order, right? It's either you move up or you move right. And from C to B, you need to move up 1 time and you need to move right 6 times. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? And any order, you arrange them in any way, C will arrive to B. Right? If you put, let's say, top in the go up here, you have right, up, right, up, right, up, right. This is what the arrows means. So the number of ways C to B is just the number of ways you can arrange this. But one thing that's important is the right here are identical. It means that if I swap these two, there's no difference. C will go to the same direction. So the number of way, you count number of object, 7 objects. So 7 factorial divided by identical object, there are 6. So 6 factorial, and this is equals to 7. Now let's see passing through D. If you must pass through D, means it's the number of way from A to D times D to B. Why? Why you multiply? Because it can be one way there, one way. Right? And this is the sign that we need to use multiplication here. So we write A to D, multiply the number of way D to B. A to D, go right once, go up 3 times. So 4 factorial over 3 factorial times from D to B, go up 2 times, go right 5 times, so total 7. 7 factorial, 2 factorial, 5 factorial. Calculate, this is 4 times 21 equals to 84. Now last one, let's see E. Same, A to E, multiply E to B. But you see A to E, there's only one way. 1 times E to B. 1, 2, 3, 4, 5. 5 times up, 2 times right. Total, 5 plus 2, 7. 7 factorial over 5 factorial, 2 factorial. And you count, this is 21. So the total number of ways is number of ways passing through C plus D plus E. So 7 plus 84 plus 21. And the answer is 112. Let fx equals to x power 2010 over x power 2010 plus 1 minus x power 2010. Find the value of f 1 over 2011, 2 over 2011, f3 over 2011 until f 2010 over 2011. One approach to this question is to notice f1 minus x. f1 minus x will give us 1 minus x power 2010 over 1 minus x power 2010 plus 1 minus x, 1 minus 1 minus x power 2010. Basically, we just change the x with 1 minus x. Now this expression, if you notice, is 1 minus 1 plus x equals to x. So this is just equals to 1 minus x 2010 over 1 minus x 2010 plus x 2010. Now if you notice, fx and f1 minus x already have same denominator. Right. So if we find fx plus f1 minus x, it will be equals to x power 2010 plus 1 minus x power 2010 over 1 minus x power 2010 plus x power 2010. If you notice, the expression above and the expression below is exactly the same. It means that it's just 1. Now looking at this, since we know that fx plus fx 1 minus x is equals to 1, I can find that this plus this is just 1. Because if this is the x, then 1 minus x will be this one. In other words, I can rearrange this sum to be function of 1 over 2011 plus f 2010 over 2011. So I'll go with the first and the last, second and the second last. Right. I pair each of them. To 009 over 2011 plus, see, until the middle one, which is 1005 over 2011 plus f 1006 over 2011. Now you notice that if I pair them up, all of this will be 1. So actually same as 1 plus 1 plus 1 plus 1. How many times? As many as the pair we have. And we have 1005 pair, right? Because if you see, this is 1, 2, and the last one will be 1005. So the answer is 1005. In the figure below, AB and CD are parallel chords of a circle with center O and radius RCM. It is given that AB is 46 cm and CD is 18 cm. Angle AOB is 3 times angle COD. Find the value of R. First, let M and N be the midpoints. So we write let M and N be the midpoints of AB and CD. It means that AM will be half of 46, 23, and CN will be half of 18, 9 cm. After that, let's also let angle CON to be X. Since we know COD times 3 is AOB, so CON, half of COD, times 3 will be this angle, right? AON. And we can write angle AON to be 3x. Now, let's see AM. Let's compare AM and CN. We know AM is 23 and we know CN is 9. But if you see, these two are radius, right? These two are same radius. So I can rewrite AM to be R sine 3x. This is 3x, right? This is R. Since sine 3x is this over this. Similarly, I would know that Cn is R sine x. Let's find the expansion of sine 3x. Sine 3x is sine 2x plus x. If you have plus, it will be sine 2x cos x plus cos 2x sine x. And then we change the 2x to be x. It will be 2 sine x cos x plus the cos x. It will become, we choose the sine 1 minus 2 sine square x sine x. From here we'll get 2 sine x cos square x. This side will have sine x minus 2 sine power 3x. This cos, we can try to change it to be 2 sine x, 1 minus sine square x plus sine x minus 2 sine power 3x. This will become 2 sine x minus 2 sine power 3x plus sine x minus 2 sine power 3x, and we'll have 3 sine x, see, sine x sine power 3x minus 4 sine power 3x. You see this one? We can cancel the r, so it's just sine 3x over sine x. If we take these two, we'll have 23 over 9 equals to sine 3x. We put in this one, 3 sine x minus 4 sine power 3x divided by 9. And this is equals to, no, not 9. We take the sine x. Now if you see sine x, sine power 3x, right? I can cancel them to be 3 minus 4 sine power 2x. From here, I can make sine square to be the subject. I can make sine square x to be 1 over 4 of 3 minus 23 over 9. If you calculate this, you get 1 over 9. It means that sine x is 1 over 3. We take the positive value since you know x is an acute angle. So if you see now, Cn, if we say just now, is r sine 3x, right? I mean r sine x. 9 is r sine x, so you can write that down. 9 is equal to r sine x. So you know that r is 9 divided by sine x, which you know sine x is 1 over 3. So it's 9 over 1 over 3 equals to 27 cm. So we know that the r is 27 cm. Right now, we are going to do this question. Find the value of this expression. 1 times 2 times 3, 2 times 4 times 6, 3 times 6 times 9, all the way until 335 times 670 times 1005. Something we notice about this pattern is that it's always in the ratio of 1 to 2 to 3. In this case, it's also 1 to 2 to 3. Even the last time is also 1 to 2 to 3. The below part also has similar pattern. It's 1 to 3 to 6, 1 to 3 to 6, and the last one also 1 to 3 to 6. Knowing that, let's say this one, I can rewrite this expression 2 times 4 times 6 as 2 times 1 times 2 times 2 times 2 times 6, or 2 power 3 times 1 times 2 times 3. Or for the last one is 335 times 670 times 1005 is 335 times 1 times 335 times 2 times 335 times 3. Also 335 power 3 times 1 times 2 times 3. Rewriting the whole expression in this format, we will have 1 power 3 is just for the first term. 1 power 3 means nothing. 1 times 2 times 3 plus 2 power 3, 1 times 2 times 3, all the way until the last one, 335 power 3, 1 times 2 times 3. Similarly, the below part will change to 1 power 3, 1 times 3 times 6, plus 2 power 3, 1 times 3 times 6. The last term will be 335 power 3, 1 times 3 times 6. If you notice, we can factorize this 1 times 2 times 3 on top, and we can factorize this below. We will have 1 times 2 times 3 times 1 power 3, 2 power 3, 3 power 3, right? All the way until 335 power 3. Similarly, below we'll have 1 times 3 times 6 times 1 power 3, 2 power 3, 3 power 3, all the way 335 power 3. Now we notice something, is that these two terms are exactly the same, right? So they cancel each other. And now we will have 1 times 2 times 3 over 1 times 3 times 6. And this one, if we see, 2 times 3 is 6, so the answer is just 1 over 3. If A, B, C, and D are real numbers such that B plus C plus D over A is equals to A plus C plus D over B, is equals to a plus b plus d over c equals to a plus b plus c over d equals to r. Find the value of r. Let's try to see this one first. We will get b plus c plus d over a is equals to r. To manipulate this algebra, let's try to add 1 on both sides. Then we will have b plus c plus d plus a over a is equals to r plus 1. We bring the a over. We have b plus c plus d plus a is equals to a r plus 1. Similarly, if we try on these two, and this one, and this one, it will give us a plus b plus c plus d equals to b r plus 1. A plus b plus c plus d equals to c r plus 1. A plus b plus c plus d will be equals to d r plus 1. Now we have 4 equations. If we add them all up, we will have 4 times of a plus b plus c plus d equals to a plus b plus c plus d equals to r plus 1. We bring this over to one side, we will get a plus b plus c plus d times 4 minus r plus 1, a plus b plus c plus d equals to 0. We can factorize out the a plus b plus c plus d. We'll have a plus b plus c plus d times 4 minus r minus 1 equals to 0. And this is equals to a plus b plus c plus d equals to 3 minus r equals to 0. This suggests that r equals to 3 or a plus b plus c plus d equals to 0. If a plus b plus c plus d equals to 0, if we see this one, it means that a times r plus 1 equals to 0. This suggests that r also can be negative 1. So the answer is r equals to negative 1 or 3. We have completed this lesson. Thank you for watching this video. I hope you have enjoyed today's lesson. Goodbye and see you again in another lesson.